in process scheduling or CPU scheduling. We discuss FCFS, then shortest job first, then we discuss the non-preemptive and the preemptive version of shortest job first. Then we discussed priority scheduling, where each incoming job or task is associated with the priority value. Smaller the value, higher the priority is. The priority based job scheduling is also of two types, preemptive and non-preemptive. So if you go for priority based scheduling, then there is an issue called starvation, where low priority process may not get the chance to be executed by the CPU for a long. The solution is aging. This solution is called aging. What is aging? As the time progresses, increase the priority of the process. That means dynamically increasing the priority value to avoid starvation. Next, here I will be discussing one of the famous algorithm is called round robin scheduling or RR scheduling. So, what is round robin scheduling? Suppose you have ready queue. All the processes are in this order. Basically in the order FCFS. So a process will be taken from the head of the queue and will be put in the CPU for execution. That is the running state. And while it is in the CPU for execution, it will be kept for a small amount of time. That is called time quantum. So a process will be taken from the head of the ready queue and will be put it in the CPUs for a delta t amount of time. Within this time, there can be several cases. The process which is in the CPU may be executed and its execution may be completed. So it will go for termination. The other case can be P1 may not be completed within this delta t amount of time. So it will be again sent to the tail of the ready queue. And the next process from the head of the ready queue will be taken and again will be kept for delta t amount of time. The same process will be continued for for P2. It will be kept in delta t amount of time. If it completes within this time, it will be terminated. If it is not completed within delta t amount of time, then again it will be sent to the tail of the ready queue. There can be third case. The process may be completed before the expiry of this time quantum. So it will be simply terminated. So it is a round.
Last possibility, sir.
The
last possibility which is, sir?
The process may be completed before the completion of the
Time quantum.
That is sound about it. Before the completion of time quantum. Okay. So what is this value? This value. Now, what is this value of this time quantum? Time quantum is ranges from 10 to 100 millisecond. So, the queue is maintained the first come first serve basis, and queue must be of large with respect to the context switch, otherwise overhead will be too high. That means it will be a repeated context switching. Now, if there are n processes in the system, what is the worst case complexity to get a process chance for the CPU? If I have a time quantum delta t,
n-1 into delta t.
n-1 into delta t. Because there are n processes, so the last process will be the nth process. Before that, there are n-1 number of processes, n-1 into delta t. Bolo. Any confusion with this?
No, sir.
Now let us take this example. There are 4 processes, P1, P2, P3, P4. The burst time is 53, 17, 68, 24. The time quantum is 20. The Gantt chart is how it will look. So we can design the Gantt chart by ourselves only. So the processes arrive in this order. So let us put P1 at the beginning. P1 will be kept for delta t amount of time, where delta t is a clear. What is the remaining requirement?
33.
Next, bring P2. P2 will be completed within 17. So no more existence of P2. What is next?
P3.
P3 will be kept for
27. 27.
so 37 plus 20. What are
57.
and what is its next requirement?
48. 48.
Next, bring P4. Keep it for delta t amount of time. So 57 plus 24. What are
77.
Hey, 7 কোথায় গো?
77.
77. And it will be
4.
4. Again, you take the round. Allow P1. Keep P1 for
97.
And its requirement is become 13.
13.
Then allow P3 for 20. কত হবে?
170.
And it becomes
28.
next P4.
It's complete. 121 complete.
121 complete. So there is no more existence of. Then again start with P1. 13. 13 is less than delta t. So 121 plus 13. It becomes
134.
and it gets completed. So there is no more existence of P1. So remaining one is
P3.
1, P4, and then again 8, because there is only one process. This is called round robin scheduling. ঠিক আছে? Now you can find out the finish time, turnaround time, average waiting time, average turnaround time. বলো, any confusion?
No, sir.
No, sir.
দেখো তো স্ক্রিনটা গেছে কিনা। স্ক্রিনটা গেছে ভাই?
Yes, sir.
Yes, sir.
লিখে নাও। Okay, and time quantum is delta t is equal to 4 millisecond. Time quantum 4 millisecond, context switching 1 millisecond.
Burst time in millisecond.
হ্যাঁ
So burst time in millisecond too.
হ্যাঁ, সব মিলিসেকেন্ডে, সব মিলিসেকেন্ডে। So schedule these processes.
Time quantum 4 milliseconds তো?
Time quantum 4 millisecond, context switching time 1 millisecond. ঠিক আছে?
Sir, arrival time এর significance থাকবে? Robin,
থাকবে, থাকবে, থাকবে in the sense you have to consider it is a first come first serve, and the second is while calculating the turnaround time and average waiting time, then you require arrival time, otherwise you can't calculate. তোমার কাছে যদি arrival time টা না থাকে, then how do you calculate? For designing the Gantt chart you don't require, but for calculating the waiting time, turnaround time, for these things you require.
तो गैंट चार्ट होएगा सर।
अच्छा
हाँ सर।
बोलो टोटल टर्न अराउंड टाइम
टर्नअराउंड টাইমটা ক্যালকুলেট করছি স্যার একটু।
করো
Sir, average turnaround time 18.27.
আমার কাছে 19.5 আছে ভাই let's see for the other people
স্যার 18.25 আসছে স্যার।
18.25 আসছে বাকি দেন অভিষেক অবন্তিকা বাসু প্রজাত কত হলো
আমি বললাম স্যার 18.25।
হর্ষিত
Sir, average turnaround time 18.25.
তোমাদের পুরো ঘুরতে ভুল হচ্ছে না তো 62401 ठीक है
Yes, sir.
P2টা কতক্ষণ থাকবে বলো তো
তো 10 to 12 থাকবে স্যার।
ठीक है then what about P3
স্যার P3 থাকবে 13 to 17।
13 to 17
17.
কে আসবে P3 আসবে না P0 আসবে
স্যার P3।
P3 আসবে স্যার
ভেবে বলো
ওকে স্যার P0 আসবে কারণ কি by the
Yes,
time
sir. P0 will be there.
because
At that time,
at the
account will-
fourth second P0 has already got at the back of the queue and after that P3
right so while P3 is coming at the 5th second or 5th position before that P0 has context switch and already in the tail of the ready queue so before coming to the P3 P0 will be coming and will be there for what
70
and it becomes
2 seconds
then what is the next
next sir P3
P3 and will be there for 17, 18.
18,
So
22.
22. And the P3 is no more existence. Next,
Yes. Sir, P1.
P1. P1, right. P1 requirement is true. No more existence of P1. P0. 26.
26.
দেখো তো বুঝতে পারলে কিনা or should I show you the queue?
স্যার একবার কিউটা দিয়ে দেখালে সুবিধা হতো স্যার।
Right. Let me show you the queue. This is my ready queue. At the beginning, there is only one process P0. P0 goes to CPU for execution. So while P0 goes to CPU for execution, while P0 is in the queue, in the CPU, P1 come in the picture. P0 is in the queue for 4 seconds. By that time, how many processes arrived? 1 and 3. That is P1 and P2. While P3 completes, P0 completes. P0 gets completed in the sense its time expiry is after 4 milliseconds. It will be in the queue. And P3 comes at the 5th millisecond, which is after P0. Next you take P1, this. Next you take P2, this. Next you take P1, this. Next you take P3, this. P3. Is this clear? So the conflict is while P0 is in the CPU for 4 milliseconds, by the time P1 and P2 already arrived. When P3 comes at a 5th millisecond, by that time P0 completes its time expiry in the CPU. Because it is time expiry is 4 milliseconds and time expiry at 4 milliseconds, as well as P3 comes in the system at 5th millisecond. So P3 comes, P0 comes before P3. বুঝলে পর্যন্ত?
Yes.
So conflict, again I am telling you, conflict is after the first round of P0 with the incoming P3. So the new P3 is coming at the 5th millisecond, while the time expiry of P0 is completed at the 4th millisecond. So P0 will be coming to the queue after the first round before the arrival of P3.
Sir, can you explain why P0 is before P5? Sorry, P3.
Why?
Sir, why P0 is coming before P3? Because P0 and P3 are coming at same time, na? 5.
No. Because P0 is completed at 4th.
And 1 second context switching time. So, fifth.
No. See. Context switching means loading to the CPU. Loading the new process P1 to the CPU. But पहले वो P1 खत्म हो गया. P0 खत्म हो गया. And whereas P3 come here in this position. But that's why the time expiry of P0 is before the arrival of P3.
Sir, if time quantum was 5 milliseconds, then what will happen, sir? P0 and P3 will both enter in ready queue at same time. Then which will come?
So in that case, I mean, see, this operating system will choose randomly. If there is a conflict means tie. If there is a tie, so the first option is you go for FCFS. If FCFS is not applicable, then you prefer take any random one. So that's why I should tell you that in the exam you don't copy with your friend, because two persons may have different answers. If you follow what is the tiebreaker you are using, if two persons follow two different tiebreaker, then answer will be different. So whenever there is a tie of time, I mean between the processes, either if there is no mention, you can follow FCFS. If there is a mention mechanism, you follow that mechanism. Otherwise, go for FCFS. If there is no mention, and if you follow different, then answer may be different. So be careful about that.
So তাহলে তো we are getting average turnaround time as 13.5, sir.
What is turnaround time?
Yes, sir.
So
No, sir, 19.5.
Yes.
19.5.
What was it?
19.5.
19.5. Average turnaround time will be coming 19.5. And average waiting time?
14.
14.
सलमान ने कहा
Huh?
Sir, how is average turnaround time 19.5? Sir,
Yes, sir. 54/4 it's coming.
yes, sir, 54/4, sir.
No.
It's 13.5, sir.
For our
That's a
system,
7.
So for
78
P0 it is
78/5 for us.
78/4 আসছে.
हाँ, sir.
Should I show?
Yes, sir, show one, sir. Because the turnaround times for P0 are 28. P1
28.
P1 is 20.
yes, sir.
And P2 is 2. P3
And
is
other
4.
one is 4.
So it's 54, sir.
That's a
P1
is
24.
24.
P1 24.
25
P2
minus
9.
P0 is 28.
And P2
P1
is
is
9.
24. P2 is 9. And P3 is 17.
17.
70.
Sir, how is P1 24?
Follow
25 minus
25
minus 5.
minus 1. 25 minus.
25 minus
25 minus 1.
25 minus 1, it completes at 25th. And it arrived at 1. So 25 minus 1, 24.
Oh, acha.
Okay. Now tell me one answer. If I have delta t, the time quantum, to a very large, very large, then what will happen? How does it work? How the round robin scheduling will work?
So
Sir, it will be
work
similar
with
to
the
FCS.
It
Sir,
will be
normal
similar to
first come,
FCFS.
first
Very
served.
good. it will be similar to FCFS. So if you choose the time quantum to a very large extent, then it will be looking like a FCFS algorithm.
Yes.
But if you choose the delta t to a very small, then what will happen?
Too many context switches.
Too many context switches. It will lead to too many context switches, and that. Bolo, Bakita, Subhishit?
Increase the utilization of CPU.
Increase.
Decrease.
Overhead.
Decrease the
Overhead.
Sorry. Overall.
If it is too many context switching, will it increase the utilization or decrease?
Decrease, sir.
decrease.
It will decrease. It will decrease the performance of the system. CPU will be more busy with the swap in and swap out of the process. That is bringing the process and swap out from CPU to back, rather than actual execution of the instruction. So CPU will be more busy with the swap in, swap out of the process rather than actual execution of the instruction. That's why that will lead to degrades the performance of the system. So this time quantum value needs to be chosen very carefully.
Sir, can you say the waiting times for this example also?
Our waiting time bola bega, chalo, next.
Yes, sir. I have calculated. Should I tell you?
Bolo.
18, 8, 18, 7, 13.
Who asked the question?
Sir,
Papuri, Miller answer.
yes, sir.
Okay. So we discussed round robin scheduling. Now there is an advancement of round robin scheduling. In round robin scheduling, we consider only one queue. There is a concept of multi-level queue. In multi-level queue, ready queue is partitioned into separate queues, mainly of two types. The first one is foreground queue, another is a background queue. Foreground queue is for interactive tasks where user is waiting for the answer immediately or user is interacting with the program. On the other hand, for background tasks, it's a kind of batch. It's a group of tasks that you have submitted to the system, and you will be, you know that your answer will be coming for a long. So you don't need to interact with the system much. So each queue has its own scheduling algorithm. The foreground scheduling normally follows Rabindranath scheduling, and the background follows FCFS. Now this foreground scheduling, either it can have some kind of fixed priority scheduling. That means each process will have a priority. Based on that, it follows round robin. Or it can have a time slice. So let us take an example. Suppose you have a you have a different processes. You put the high priority process, the process which are system related process. You can put higher priority. Then interactive process, there you can put this type of. I mean the order of priority is like this. This is higher order priority, this is the lower order priority. Interactive process, then interactive editing process, batch process, and the lowest most is the student process. That means you are maintaining a server and different types of tasks and processes are coming. So operating system is maintaining different types of tasks in a different category. So system process, interactive editing process, batch process, and student process. Maybe you can give the priority to these processes. This can be one approach. The other approach can be, you can put these processes to a larger time quantum and then smaller time quantum. That means the processes which are of high priority, you can put larger time quantum, and the lower priority processes are given lower time quantum. This way also can be scheduled. For example, you can allocate 80% of the CPU cycle to the foreground task and 20% is for FCFS. So as I told that you can partition your task into two types. One is the foreground task, the interactive task. Another is the background task, the batch processing task. And how will you allocate the CPU cycle? 80% you are putting to interactive processes and 20% is for the background task. The foreground tasks are the interactive tasks where user is waiting for the answer immediately or user is waiting for some kind of interaction with it. Whereas for the background task, once you submit those tasks, you will be waiting for a long to get its answer. I mean, you know that the answer, it takes a long time to get the answer back. So this way multi-level queue can be designed. There is another way of multi-level feedback queue. What is that? Just let us take example. Then I will be coming to the theory. Initially, whenever a process comes in the system, it will be given a time quantum of 8. 8 is an example. So the delta T amount of time is 8 milliseconds. It will be put in the CPU for execution. Within this time, the process may be completed or it may require some extra amount of time. If it is completed, it will be terminated from here immediately. If it is not terminated or it is completed within 8 milliseconds, then operating system will try to predict that instead of 8 milliseconds, it may require a higher time quantum. So it will be sent to the next queue, that is of time quantum 16. So it will be sent to the CPU for 16 milliseconds. If within that 16 milliseconds, if it completes, it will be terminated from here. If it is not terminated, then operating system will try to predict that it is of lengthy process. So I should give it to the next level, that is FCFS. That means where once a process is scheduled, a process will be there in the CPU unless it is completed. So this is called multi-level feedback queue. So each process at the beginning will be given to the lower time quantum. If within that lower time quantum, if it is completed, fine. If it is not completed, then it will be given to the higher time quantum. and will be sent to the CPU for execution. If it is completed, fine. If it is not completed, it will be sent to the next queue whose time quantum is higher. Bolo. Is this idea clear?
Yes, sir.
That's why it is called multi-level feedback queue. Every time a process gets executed by the CPU, a feedback will be generated. Feedback, whether it is completed or not. If it is completed, fine. If it is not completed, then it will be sent to the next higher level of queue with a higher time quantum. Again, the same procedure will be followed. চুপ মেরে গেল কেন?
Sir, if there are many levels, then lot of time will be wasted in pushing the process from one to other level.
Yes. So again, you need to choose that how many level you can put. Maybe 2 level, then FCFS. So once you put it in the FCFS, there is no more switching, because in FCFS, once it is in the CPU, it will be in the CPU till it's completed. So that's why first queue, second queue, and the third queue is the FCFS. Maybe first queue, second queue, third queue, and the fourth queue may be FCFS, because the FCFS is the highest. In our earlier example, we also discussed. In our earlier example, we also discussed that if you increase the time quantum to a large extent, then it will lead to the algorithm that is called FCFS. So, a multi-level queue, a process can move between the various queues. Aging can be implemented in this way. Like, if it is not completed, you shift it to the next. Multi-level queues should define the following parameter. You need to find same number of queues, maybe 3 queues. Scheduling algorithm for each queue, maybe with a time quantum value, or it can be FCFS type. Method used to determine when to upgrade a queue. You have to define the method when it will be shifted to the next higher level queue. Method to determine when to demote a process. Method used to determine which queue a process will enter when the process needs services. So depending on the requirement of the processes, you need to dynamically, you are changing the queues. ঠিক আছে?
Sir, last point টা বুঝলাম না sir.
The method used to determine which queue a process will enter when that process needs services. Services means it's a kind of, maybe in a particular type of service you are asking for, maybe one queue is looking for some different specific service. So you need to put it in that particular queue. I mean, what type of service it is looking, in that particular queue you will be putting. So operating system will be dynamically choosing that value, choosing that decision. That is the decision of the operating system. That operating system will dynamically select that at the beginning, let us put the process in the first queue. If it is completed, fine. If it is not completed, you shift it to the next queue. That this entire decision will be taken dynamically. That is the thing. ঠিক আছে? So if we summarize the whole thing, if we summarize our whole scheduling technique, then it starts with FCFS scheduling algorithm, then your shortest job first scheduling algorithm, then priority scheduling algorithm. Both shortest job first and priority scheduling algorithm, they can be of preemptive type and non-preemptive type. Then we have round robin scheduling. Using round robin scheduling, we discuss some example. Then we have multi-level queue, where some processes are kept in a round robin scheduling, some processes are kept in a FCFS. The processes which are of interactive type are kept in a round robin scheduling. The processes which are of batch type are kept in a FCFS. Next, you have multi-level feedback queue. Every time a process is executed in the CPU, a feedback will be generated. And based on that feedback, operating system will try to find out that where to promote this particular process, whether it will be sent to the next queue or not. Now, one important thing you have not considered in our entire discussion. You see, in every example we consider that the burst time. What is this thing? Can anybody say? I have already discussed, of course, but what is this?
For the amount of time the process in the CPU, like the amount of time it's getting processed in total, the amount of time it takes to get processed.
You can take the help of this slide.
So what I said, basically all logical processes done by the CPU is done within the burst time, sir. So the CPU burst, like there's a alternating sequence of CPU burst, IO burst, CPU burst, IO burst. So the sum of all the CPU bursts is the total CPU burst time.
And is a total CPU burst time. So
It does not include IO.
That means a process composed of alternative CPU burst and IO burst. Process composed of alternative CPU burst and IO burst. Alternative collection of CPU burst and IO burst. So when you are scheduling, you are checking what is the next CPU burst time. Depending on that, you are going for either FCFS or shortest job first, whatever.
Sir, but in real life, is it possible to calculate the burst time?
Exactly, that is my discussion. That is my starting of the discussion today's class. I mean, just a small discussion. In real life, can you really find out this value? Can you really find out this value? Can you really find out this value? क्या बोला सौरभ बोला नहीं सौरभ?
Yes, sir.
Why?
Any process, sir, CPU is so fast. I don't think to accuracy will be so less in this, sir.
CPU burst time basically that particular process composed of some kind of executable instruction in that particular that burst time. Now it depends on many things. Depending on the machine where you are executing, depending on the current load of the machine. So that's why if you execute the same program in two different machines, it will be executed in it will take different execution time depending on the hardware architecture. Even if you have the same machine, depending on the current load, I mean current load means what are the other processes are currently being running on that machine. So there are so many things that decides the burst time. So you cannot determine it. You cannot determine it. You can predict it. What is the difference between predict and determine?
So predict means an
There is
approximation.
an error.
Accurate value.
बोलो confused ये है गाला
So predict means approximation of how much it might require, but determine means absolute accurate value, exact value.
तुमरा ऑपरेटिंग सिस्टम में कितना मिलेगा? प्रेडिक्ट कर रहे हो, डिटरमाइन कर रहे हो?
Sir, predict.
Predict.
कर रहे हैं
Predict.
What are the factors you are using to predict this?
प्रिपरेशन से
Attending all classes.
Just preparation, Saurabh,
Attendance, sir.
और
Exam.
कंसंट्रेशन
Level of difficulty of question paper.
और
On the teacher.
Sir,
How much?
Sir, mode of
क्या बोला?
exam,
आपने
sir.
क्या बोला?
Teacher also. On the
Teacher also. So the
Sir,
same
mode of
subject.
exam, sir.
Huh?
Mode of exam. Is it
Exactly,
online or
mode of
offline?
exam. Very good. Honest person. Saurabh is very honest.
Thank you,
Saurabh
sir.
is very honest. So the mode of exam and the
Teacher.
feedback and the feedback you receive from your batchmate, maybe from other branch like civil, or maybe the feedback you receive from your senior about the teacher and the subject. So there are a lot of factors with which you can predict that operating system में ये आ सकता है या EX आ सकता है. So you can predict, but you cannot determine. In the same way, CPU burst time cannot be determined. You can predict it because there are so many factors that will be associated with this. In that particular moment, what is the load of the computer? What hardware architecture you are using? Is my point clear? So whatever values we are considering, just for our mathematics we are considering these values, but this only can be predicted. This only can be predicted. You cannot determine this value. This can be predicted. This can be predicted. Based on the predicted burst time, we have to schedule our processes. Follow. Is the concept clear?
Yes, sir.
So
Now, how will you go for prediction? The prediction criteria is very simple. The class of it. Determine the length of next CPU burst time. It can only be estimated or predicted. It can only be estimated or predicted and can be done by using the length of previous CPU and using the exponential averaging. How? Suppose Tn is the actual length of the nth CPU burst. Tn is the actual length of nth CPU burst. And tau n plus 1 is the predicted value for the next CPU burst, where alpha is a factor. Alpha ranges from 0 to 1. So, tau n plus 1, that is the predicted value for the n plus 1th process, is alpha into Tn. Tn is the actual length of the nth CPU burst time, because we are going to calculate n plus 1th. while we are calculating n plus 1th CPU burst time, that time already we have covered the nth execution. So tau n plus 1 is equal to alpha into Tn plus 1 minus alpha into tau n plus n. So tau n plus 1 is the predicted value for the next CPU. So tau n is the predicted value for nth CPU burst.
Sir, alpha, sir?
Alpha is a kind of factor, or you can say is a kind of probability that you are putting on this and some probability you are putting on this, or you can say it is a weightage. কোনটাতে কত weightage দিচ্ছ?
Sir, will alpha be constant?
सौरभ ने जो बोला, Saurabh is putting more focus, 90% focus on the mode of exam it is happening. Abdul is giving the more focus, more weightage on the teacher who is taking the class to predict the marks of operating system. তাই তো সৌরভ?
Yes, sir.
হ্যাঁ বলো, কোন বলো? সতীশ কি ক্ষিতিশ কি বলছো?
हाँ sir, will alpha be constant throughout the system? So will alpha be constant?
No, alpha is not constant. Alpha should be ranges from 0 to 1. That means how much percentage you are putting the focus on Tn and how much weightage you are giving on tau n. Now you can tune up this value depending on the requirement, or you can dynamically change it.
Okay.
যেমন এখন প্যান্ডেমিকের সময় সৌরভ বা সবাই তোমরা ওয়েটেজ দিচ্ছ কিসে?
Mode of exam.
কিসে?
Sir, are you asking with me, sir?
I'm asking to everybody.
Connectivity.
Connectivity. I'm asking about the marks on the subjects, or predicted marks on the subject. Maybe in the end sem or mid sem or whatever.
The difficulty of paper.
যদি নেটওয়ার্কের ইস্যু হয় তো তখন অনেকের প্রবলেম হয়ে যায় লাস্টে, তো ওই কারণে।
ওটার উপর বেস করে কারণ রেজাল্ট কম বেশি হয় নাকি?
স্যার আমাদের হয়েছিল,
সাবমিশনে হয়, মানে মুডে ক্র্যাশ করে।
যাই হোক, আমি তোমাদের জায়গায় থাকতাম তাহলে মোড অফ এক্সাম।
I said mode of exam.
ঠিক আছে, so mode of exam will be having more weightage rather than the difficulties of the paper or the teacher who is taking the class. If the mode of exam is online and MCQ based, then all will get A or EX. That is your prediction. But if the classes is going on in online mode, but suddenly you have to come for physical exam, then the entire weightage will be, you need to readjust to predict the marks of operating system. You have to give more weightage on the preparation rather than mode. Am I right?
Oh yeah.
Yes, sir.
Okay, so this way you can predict. Again, I am telling you, this way you can predict, but you cannot determine. Predict is for future. You are predicting the future. You are estimating the future, not the actual one. If it is an actual one, then it should be determined, where everything you know. So that's why burst time or next CPU burst time can be predicted or can be estimated, depending on the past experience what we had. So the past experience is the actual length of the nth CPU burst time and the predicted length of the nth CPU burst time. With this thing, we are trying to predict the n plus 1th CPU burst time. And if you plot it in practical scenario, then you will find like this: CPU burst time and the guess value. So this is my tau, and this is T, and this is my tau.
Sir, in the graph, sir, which one is? আচ্ছা দেখতে পাচ্ছি না। আচ্ছা হ্যাঁ বুঝতে পেরেছি স্যার।
দেখো দেখা যাচ্ছে। এটা হচ্ছে টাউ তোমার, যেটা তুমি প্রেডিক্ট করছো, আর এটা হচ্ছে অ্যাকচুয়াল। ওই জন্য অ্যাকচুয়ালটা at the beginning you are not getting. At the beginning you are not getting the actual one. So at the beginning you are taking anything as consideration, and then you are trying to calculate.
Yes, sir. Because for the beginning there is no n-1.
Yes, yes. ठीक है? Here. बोलो कोनो confusion है? ठीक है तो
Sir, but for n equals to 1, you have given one formula in the previous slide, sir. Define t n equals to 1. The fourth statement, sir.
हाँ, वही तो मैंने लिखा यहाँ पे, वही मैंने यहाँ लिखा।
Yes, sir. So tau equals to 1, it can be calculated, sir.
I guess it is tau n plus 1.
Tau n plus 1 ঠিক করে দিলাম, এটা ভুল আছে।
স্লাইডে টাইপো আছে।
Actually slide n equals to 1 লেখা আছে।
না না, এটা ভুল আছে, স্লাইডে ভুল আছে। ওটা আমি চেঞ্জ করার চেষ্টা করেছি, পারিনি করতে। এটা
Okay, sir, got it.
আর স্লাইডগুলো তোমরা পেয়ে গেছো তো সবাই?
Yes sir, yes sir, zip টা পেয়ে গেছি।